Welcome everybody. I'm Marco Palladino, the CTO and co-founder of Kong. Today, I'm very excited to present to you Kong Mesh distributed across multiple clouds, multiple clusters, including a hybrid of virtual machines and containers. Kong Mesh really is the result of many months of work that we've been doing with the user community, with our customers, to make sure that we could build the most sophisticated multi-cloud, multi-region service mesh that the industry has ever seen. And today, I'm going to be giving you a very quick explanation as to why Kong Mesh is important, but then we're going to be diving deeper into the product and we're going to be seeing a live demo. I'm going to fire up the terminal and we're going to be deploying Kong Mesh in a distributed way across multiple clusters. We're going to be seeing it running across multiple clouds live into this session. I'm very excited for what I'm about to show you. If you have followed the keynote, you have learned that we have released a new product, Kong Connect. And if you have followed the keynote, you also have learned that we spoke about Service Mesh and how important Service Mesh is in the overall connectivity journey that every organization has to implement. For Kong, Service Mesh, it's not a siloed concern, but it is a very important part of the overall connectivity journey that we have to build for our application teams. So Service Mesh is very well integrated with our Kong Connect platform to enable seamless connectivity that goes all the way from the gateway to Service Mesh, all the way from north-south traffic to east-west traffic. In Service Mesh and Kong Mesh, like any other products that Kong creates, it is a platform agnostic product that can run on virtual machines, can run on Kubernetes with native CRDs, and it can run pretty much on any cloud, any platform, including physical data centers. And so this didn't happen by chance. There was lots of effort that we put into Kong Mesh to make sure it could support every application team that we have to support when it comes from a connectivity standpoint, when it comes to Service Mesh. So let's look deeper into Service Mesh. As part of our work with Kong Mesh, which is our Service Mesh product, we did release Kuma, our Service Mesh project, to the broader community. And Kuma really is the underlying foundation of Kong Mesh. Kong Mesh, like Kong Gateway, like anything that we do, is an open source foundation. We believe that modern infrastructure is open source. And so even in the case of Kong Mesh, it is built on Kuma, which is an open source foundation. Even more so, it is a project that has been donated and accepted into the CNCF Foundation as a sandbox project, as the first service mesh that's built on top of Envoy that has been accepted into the Cloud Native Foundation. Now, it provides a very unique set of features that I'm going to be exploring today with you. This very unique set of features have really created a tremendous adoption when it comes to both users and customers on top of Kuma and Kong Mesh. So we can see that the adoption over the past 6 months has been incredible. We've more than doubled the number of instances running of the control plane. We've created more than 500% of virtual meshes running on top of Kong Mesh and Kuma. This is an incredible milestone for the product. Kong Mesh is being used for typically, traditional, typical service mesh use cases. Among them, we can identify 3 use cases that are perhaps more important than the others. First and foremost, as we transition our applications to microservices, as we build more and more of those services, it is very important that we can connect them reliably. And so Kong Mesh is being used today to connect those services, to discover them. It provides a built-in service discovery that can run in a single zone or a multi-zone deployment, as well as it enables reliable traffic from one service to another. Once we have all of our services connected with each other, it is important that we can secure them and we can apply not only an identity to each one of them, but we can also then encrypt the traffic that we're sending. And so Kong Mesh, it is being used today to implement zero trust security models in one click that allow us to implement a certificate authority of 3 different kinds in Kong Mesh. Either we can connect Kong Mesh to a third-party PKI like HashiCorp Vault, for example, or you can ask Kong Mesh to create that root certificate and key automatically. And then once we have decided how that CA works, we can automatically issue and rotate certificates for each data plane proxy. It's very easy to use, and we're going to be seeing it in the demo. As well as for observability. The more connections we have, the more services we have, the tougher it's going to be to understand where problems are. And perhaps the problem is not in our application, it is in the connectivity layer that connects these applications and services together. And so with Kong Mesh, we can enable out-of-the-box traces, out-of-the-box metrics, out-of-the-box logs that we can push either into our Splunk or Logstash, or we also have a native integration with Prometheus and Grafana. So there is a lot of work that has gone into Kong Mesh to make sure that all of these major use cases are not only taken care of, but also easy to use. And simplicity really, I believe simplicity is a feature, and simplicity really has been something that we'll be putting lots of effort when it comes to our service mesh product and project. From a 10,000 feet high level overview, Kong Mesh is a control plane for service mesh that implements the XDS API that Envoy supports. We are supporting Envoy natively, but in order to use Kong Mesh, we do not need to know Envoy. We make it easy for anybody to deploy a service mesh without having to have any prior experience with Envoy. But of course, we also give a chance to the power user to go a little bit lower level if they want to then configure the low-level Envoy filters or whatever that is. And so we can access the full power of Envoy if we want to, but we don't have to. We are abstracting away the bootstrap configuration. We're abstracting away all of that complexity so that the product is easy to use. It supports Kubernetes natively on both the control plane and the data plane, and we support virtual machines as well on both the control plane and the data plane. As a matter of fact, if we deploy Kong Mesh on Kubernetes, we can configure the service mesh resources using CRDs, native Kubernetes resources using kubectl. And if we're using Kong Mesh on platforms other than Kubernetes, we can still use the product, but we provide our own CLI called kubectl that we can use to change the state of the resources using a YAML declarative configuration file. So we make it easier for Kubernetes users as well as users that are not on Kubernetes yet to still be able to deploy a service mesh that is not just meant for the new greenfield applications that we're going to be deploying, but also for where the business runs today. So if today we have virtual machines running, today we can run Kong Mesh. We don't have to move to Kubernetes first in order to use it. We can also mix and match Kubernetes in virtual machines, and this is what this demo today it's all about. It is built for the enterprise architect. It is built for the architect that has to support connectivity across multiple applications, multiple teams, multiple lines of businesses, and we need to be able to do that in a scalable way. So with Kong Mesh, we introduce multi-mesh support, for example, which allows us to create as many virtual meshes as we want on top of one control plane. And then if we want to update the control plane or all of these service meshes, we can do it from one deployment of the control plane. We don't have to do it for multiple deployments. As you know, other service meshes, if we want to support multiple meshes, we must deploy a new cluster of the service mesh for each mesh that we want to create. Not with Kong Mesh. With Kong Mesh, we deploy Kong Mesh once and only once, and then we can support as many meshes as we want. This makes it very easy to support the entire organization. It also makes it, it reduces the team coordination that is required when operating within, when managing the mesh. And also it improves the security of managing the mesh because there is no way another team can do something that breaks the application of another team if we compartmentalize each teams and each application in its own service mesh. It is easy to install, it's easy to use, it's easy to scale. Simplicity really is a feature. And like I said, it is built on top of an open source foundation, Kuma and Envoy, both part of CNCF. Kong Mesh has a very unique set of features that it is not going to be found in other service meshes. It is a multi-mesh product, which means that, like I said, we deploy Kong Mesh once, we create as many meshes as we want. It is universal. It runs on top of Kubernetes and virtual machines. It runs across any cloud. It runs across any environment. And we can also mix and match those environments. So if we do have a multi-cloud organization, if we do have a hybrid of virtual machines and containers, with Kong Mesh, we can support them all. Kong Mesh can also run on environments that typically other service meshes do not support, like Amazon ECS or Fargate. all of these platforms are supported by Kong Mesh. We provide some features that are quite interesting, like the attribute-based policies. Every service that it is part of the mesh, not only it's going to be automatically injected with a sidecar proxy that's built on top of Envoy, but then we can also add attributes for each replica of our services. And for example, this has been quite useful for some of our customers. For example, financial customers, some of them have traffic that cannot leave the country. There's certain traffic paths that cannot leave the country. And so they tag each workload with a country attribute, and then they can apply routing policies on Kong Mesh with on top of those routing, on top of those custom attributes, which makes it very versatile and quite fine-grained in how policies can be applied. And like I said, it provides the best built-in multi-zone connectivity that the industry has ever seen. It not only connects services from different regions, different clouds, different hybrid Kubernetes and virtual machines, it also automatically synchronizes and propagates the service mesh policies from the global control plane to the remote control planes. And we're going to be looking into this in a second. In general, service mesh has two main benefits when it comes to our organizations. First and foremost, it makes the application teams more efficient. If the application teams do not have to build connectivity, do not have to build observability, do not have to build security, that's more time they can spend building what they should be building, the applications themselves. So with Kong Mesh and with a service mesh in general, we can make the application teams more efficient because they don't have to build all the things that service mesh provides. And the thing is, if you do not use a service mesh, it's not that those concerns go away. We still have them, but today the application teams build them. And so it makes the application teams more efficient, while at the same time, it gives us control of the connectivity that's being generated across any service, any application within the organization, across any team and any environment. And this is very important. Connectivity is at the backbone of any modern application. If connectivity is down, our applications are down. So connectivity must come as part of the underlying infrastructure provisioning that we do when we create an environment for our teams. And so if there is a team wanting to deploy on Kubernetes, we could typically provision a Kubernetes cluster. And as part of that provisioning, service mesh already comes built in so that connectivity is already taken care of for them. It is built on top of Envoy, which is one of the most used data plane proxy technology in the world. The entire industry is rallying around Envoy. I'm pretty sure you're familiar with Envoy. And we at Kong know Envoy very, very, very well. And so we built our service mesh product on top of Envoy in order to leverage all the functionality that Envoy provides, and yet being able to manage it with a modern service mesh. Zero trust security is very important. Zero trust security means that we're building our architectures with zero trust, as if we were not trusting any service or any request that's being processed in our systems. And to do that, we need to be able to assign an identity, a certificate to each proxy that runs within our systems, so that each request is identified, and most importantly, it's also encrypted. And so all of this is one click with Kong Mesh. And zero trust security, perhaps it is something that many organizations are looking at from in the office of the Chief Information Security Officer. So the mandate of making sure that the organization is compliant, the mandate of making sure that we can tighten up that security to create not only mutual TLS encryption and identity, but then also traffic permission, ACL, to determine what services can consume what other services. And like I said, observability, it is a concern that comes out of the box. It's a feature that comes out of the box with Kong Mesh. With traces, we integrate with Zipkin, with Jaeger, with Prometheus, with Grafana. We also provide the out-of-the-box dashboards for Grafana to get up and running immediately, as well as we can publish our metrics and logs and traces to any third-party system. And so we can, for example, integrate Kong Mesh with Datadog. We can integrate Kong Mesh with Splunk, with Logstash, whatever we're using, Kong Mesh will support it. And because of the routing capabilities of Kong Mesh, we can also then deploy different version of our services and then apply routing rules for Blue-Green or for Canary to streamline how our application teams are pushing their software in production. All of these are things that we can do for not just the APIs we're building, but like I said, for anything we're using, anything that can open, that can receive or make a request over TCP, it is a service in Kong Mesh. And Kong Mesh creates this network overlay that makes that connection among the services secure, protected, reliable, observable, and routable in a very consistent way. So let's go deeper into multi-zone and what that means for Kong Mesh. Kong Mesh can be deployed like Kuma in two different ways. It can be deployed in a standalone mode, or it can be deployed in a multi-zone mode. Standalone mode, it's quite simple. It is what every other service mesh does. So you can run your mesh within the context of one cluster, of one platform, one cloud. You do not expect to add any other clouds or platforms. And basically, it's a single region deployment of the mesh. But obviously, if we're building a distributed organization, chances are we're using different regions, different clouds, different Kubernetes clusters even. We may even have a mix of them. And so for these more complex networking deployments, we do have another deployment mode, and it's called the multi-zone mode. Now, when running a service mesh in a distributed way, in a multi-zone way, there is usually a couple of problems. The first problem is being able to propagate the service mesh policies that we set up across every zone. And then the second problem is connecting services and discovering services that are running across different zones and enabling that cross-zone connectivity. Now with Kong Mesh, we have a very unique approach when it comes to solving these problems. We introduced a global and remote control plane separation. So we're going to be having a global control plane that we can deploy somewhere. Can be on Kubernetes, can be on virtual machines, it doesn't matter. And in the global control plane, it is going to be the right control plane, the one that we're going to be using for changing the state of our service mesh. And then we're going to be having as many remote control planes as the zones that we want to support. And a zone can be a platform, an AWS VPC, can be an ECS environment, can be anything. We can slice and dice it however we want. It can be a physical data center for example. And we're going to be having a remote control plane for each zone that we want to support. In the remote control plane, it is going to be connecting to the global control plane to enable that propagation of service mesh policies. We have extended the XDS protocol that Envoy utilizes to communicate with the remote control plane. We've extended that to introduce an XDS-like protocol for the remote control plane and global as well. We call it KDS, Kuma Discovery Service. That means we effectively have HTTP and gRPC communication all the way from the data plane proxies running next to our services, all the way to the remote control planes when it tries to communicate with the global control plane. So it's HTTP2, very quick, very fast connections all the way through over gRPC. We propagate our service mesh policies using global and remote, and then we automatically discover services in each zone, and we automatically advertise their services addresses and the services name across each zone. And then we enable the connectivity from one zone to another by providing an out-of-the-box ingress that we're going to be using for in-mesh connectivity across different zones. This is different from the ingress controller. This is an ingress for the mesh. Then once we have all the services running in the mesh, we can use an ingress controller to decide to expose some of those services via an API gateway like Kong Gateway, for example. Now, this is very powerful, and quite frankly, it is harder to explain than to show you. All of this comes out of the box. So when you install Kong Mesh, you can decide to install it in global mode, in remote mode, and we already provide the discovery out of the box, and we already provide that ingress out of the box. So there is nothing that we have to figure out on our end. It just works. We deploy it, we run our service mesh in a distributed way, and it just works. And I'm gonna be showing you this live today. I'm going to be showing you other things as well. So for example, Kong Mesh provides a GUI that we're going to be using to explore the state of our resources, as well as a CLI, as well as an HTTP API. This is a highly extensible system that can also be very easily integrated across pretty much any environment. And we're going to be using policies to enhance the service mesh. In Kong Gateway, if you're familiar with Kong, you install Kong, you add your APIs on Kong, and then you can add plugins on Kong to determine, how we secure, for example, APIs. In Kong Mesh and Kuma, we don't have the concept of plugins, but we have a very similar concept. It's called policies. And so once we deploy the mesh, once we deploy our services, we can add policies to our mesh, like mutual TLS, like observability, to enhance what the mesh does among all of our services. And because it runs everywhere, Kong Mesh can also be used for to accelerate that Kubernetes transition. We can deploy our Kubernetes workloads next to our virtual machine workloads and connect them together in a seamless way. So when we transition to Kubernetes, we don't have to do it all at once. We can do it step by step and using traffic routing rules to determine how much traffic goes to the VM version of a service as opposed to the Kubernetes version of the same service. We can also have different services, some of them running on Kubernetes, some of them running on VMs, talking to each other. It is very powerful because it really opens up many possibilities when it comes to modernizing our overall architecture. And Kong Mesh can also be used for cost reduction. Kong Mesh, because it implements a service mesh, because Service Mesh implements a client-side load balancing a pattern, we can get rid of expensive enterprise load balancers in front of our services. We've been working with customers that were able to reduce costs, reduce 7 figures or 8 figures just by getting rid of all the enterprise load balancers they have running around, because those are not required anymore once we're on a service mesh. The service meshing, because it provides client-side load balancing and a built-in service discovery, does not have to go through a load balancer. It load balances on the sidecar, which means that we also reduce an extra hop in the network. Therefore, we can improve the performance of the overall architecture. And this has been very, very powerful, especially in these very difficult COVID times where some organizations are looking forward to modernize and innovate, but at the same time, they're also looking at ways to reduce cost. And so Service Mesh and Kong Mesh has been a great way for our customers to do that. And of course, it integrates in the overall big picture of our connectivity platform. And so we can create meshes using Kong Mesh for each product, each team, each application that we want to connect. And then if there is a subset of those APIs that we're connecting that we want to expose either internally to another team or we want to expose at the edge, then we can use the integration with Kong Gateway. And the integration with Kong Gateway just works. We don't have to build it ourselves. There is nothing to glue together. It is a native integration. It's a native experience. So we're going to be creating as many meshes as we want for as many applications as we have. And then once we want to enable some traffic from another team, another app, or at the edge to consume some services within that application, we can use that Kong Gateway integration. Kong Gateway, effectively, it is the ingress and egress of Service Mesh. But unlike many other service meshes, this is a top-notch gateway ingress and egress that provides hundreds of features that we can use in addition to the Service Mesh functionality. When used together, it is very powerful. Okay, so let's not waste any more time talking about it. Let's watch it. Let's see it in action. So I'm going to be showing you a couple of things today. First, I'm going to be showing you the environment I demoed at the keynote. We had at the keynote, we had our demo application being deployed across multiple clouds, across multiple platforms. So what you're looking at right now, this is a service mesh that runs simultaneously on Amazon, AWS, and Google Cloud. And it runs on multiple Kubernetes clusters within Google Cloud. And also it runs on VM EC2 environment on AWS. So this is a distributed mesh across multiple regions, multiple clouds, hybrid between virtual machine and containers. And we're using Kong Mesh to secure it all. Now, when it comes to managing this distributed service mesh, we must have a global control plane, like I've explained. So let's go ahead and look what's inside of this global control plane, and then let's go ahead and see and pull up the GUI to determine what is the state of our resources within our distributed mesh. So right now I'm connected to the global Kubernetes control plane. I'm going to be fetching the namespaces, and you can see that among them, we have a Kuma system namespace. And then if we inspect the pods in here, we see that there is a control plane. So we can expose this control plane very easily by using the port forward command that Kubernetes gives us, and then we can expose on the port 5681. Now, if I do that, this will expose the API of Kuma in this case, but then it will also expose the GUI. So, you know, the API, by the way, can be used to integrate the service mesh with anything that we're running. Our automation can hook into this. But if we go on /GUI, we can then pull up the GUI, and the GUI is built on top of the same API I just showed you. Now, if you load the GUI, we see that in this case, we're going to be having, there is 3 zones, there is 2 meshes, there is 9 data planes. So if you look at the zones, we see that there is a zone on AWS, on VMs, on GCP, GKE East, and GCP, GKE West. And then we have our data planes running in each one of these different zones. And so we can tell which zone belongs to each data plane by looking at the Kuma.io zone attribute. And we see that there is an ingress for you know, the AWS region. Then there is Redis. Our demo app, it's a very simple app. It's made of 2 services. There is a demo backend, and then there is a Redis service. And so the demo backend allows us to increment a counter on Redis. And so we do have a Redis deployed on AWS. We do have the demo app deployed on AWS on VMs. And then we have the same thing on Kubernetes East, and then the same thing on Kubernetes West, and so on and so forth. So we basically have distributed our application. So in the keynote, I showed you this demo. We were able to go to the demo app, and I need to log in again. My session has expired, so let's do that. But perhaps actually I can show you this. I think I already had it stored somewhere. There we go. So this is basically the address of the demo app on AWS. And so if I increment, if I auto increment the counter, if I increment the counter, we can see that the traffic is going from AWS on VMs, it's going to GCP. And if I auto increment, we can see how we are, you know, effectively load balancing between virtual machines on AWS and GKE West and East. Of course, right now I do have a traffic routing rule that is determining this behavior. I can go ahead and fetch the traffic routes that we have created. And by the way, we can also use the GUI for this. So there is a traffic route here that basically is telling to redirect all traffic from that's being made from the demo app to Redis, 50% on GKE West, and then 50% on GKE East, on Redis on GKE East and Redis on GKE West. But of course we can change this. So for example, we can say that we want to run this traffic in such a way that, let's say 30% goes there, 50% goes here, and then we can add another weight, for example, of 20, and say that, you know, those requests are going to virtual machines, to AWS. And so I can apply very complex traffic routing rules that determine the behavior that we're going to be enforcing when it comes to multi-zone connectivity and routing. Now, this is, I'm going to be starting a new environment, so I can show you how to set this up. But if I go and apply this policy, oops, I need to echo this command in a valid kubectl apply command, of course. Now, if I do this, we can see that because I added, one second, wait, 1 second, there we go. Because I added AWS as one of the environments that I want to be using, we should be seeing, you know, every once in a while an AWS counter that's being increased. The counters are different because we're going to be increasing different Redis servers, each one on its own region. And so we're going, depending on which one we're hitting, the counter is going to be different. Now, this is a service mesh that automatically provides this multi-zone connectivity across containers, across VMs, and that automatically enables mutual TLS across the entire connectivity. Let's go ahead and set this up from scratch. So instead of using the same environment I had at the keynote, let's go ahead and set up a new environment of Kong Mesh in a distributed way. And I'm going to be following public instructions to do this so that you can replicate this at home by yourself. So I do have another environment here for Kong Mesh multi-zone, and these are empty clusters. So let's go ahead and connect, for example, to the global control plane. Let me close this and start a new connection to another Kubernetes cluster. This is empty. So if we inspect the namespaces that are available here, we see that this is an empty Kubernetes cluster. So let's go ahead and follow the same instructions that we have in our official documentation to determine how to deploy this with Kong Mesh. So first and foremost, you can deploy Kong Mesh by going on konghq.com. You can go on docs. And if you go on docs, you can go on Kong Mesh. And then from Kong Mesh, there is an installation guide that tells us what we have to do to make this work. But of course, we can also follow the instructions, and the instructions of Kong Mesh. Kong Mesh is a drop-in replacement for Kuma. So all that Kuma can do, Kong Mesh can do, but then Kong Mesh can do much more in addition to that. So let's go ahead and deploy Kong Mesh in a multi-zone mode. So first and foremost, we have to deploy our control plane. Now, in order to deploy the control plane with Kong Mesh, we also need to pass a license path. So I'm going to be creating the commands that I'm going to be running and passing the path. I believe I do have a license here that I can use. There we go. So I'm going to be installing a control plane in mode global, and then I'm going to be piping all of these in kubectl. Simple as that. You can see that if I type kubectl version, this is the Kong Mesh version 1.0.2. So let's go ahead and install this global control plane. So if I do that, we are going to be installing the global control plane on that Kubernetes cluster on GKE that I've connected with it, to. And if you look at the namespaces, there is now a Kuma system namespace. And if you go look at the pods within this namespace, we can see that our control plane is initializing. This shouldn't take a long time. As a matter of fact, it's not working. And we can port forward our control plane to look into it, and see what we've got. There we go. So let's go ahead and access the GUI. And this is an empty cluster of Kong Mesh. You can see that this is a Kong Mesh. There is no zones. There is only one mesh, the default mesh. We can create as many meshes as we want, like I said. And each one of them is going to be isolated from each other. And then there is 0 data planes. There is nothing. It's an empty cluster. So let's first, before we even provision our demo application, I want to make these other Kubernetes clusters part of this distributed service mesh. So let's connect to the east control plane. But before I do that, let's fetch the address of the load balancer that has been provisioned by GCP. We are going to be needing this to connect to the control plane from the remotes. So we can see that the external IP for the global control plane, it's here, and this is the port. So I'm gonna just save this because we're gonna be needing it in just a second. So the global address is this on 5685. So this is the port. So let's go ahead and also install the remote control plane. Installing the remote control plane it's very similar to installing the global, but we have to pass some additional properties. So first and foremost, this is a remote control plane. We're going to be having assigning a name for this control plane. So the zone can be, this is the east zone, let's call it east. And let's put the address here of the global control plane. And so this is the address of KDS for the global, there we go. And then likewise, let's pass the license path for our license, and that's it. So once we do that, we can connect to east. I forgot if I've done it, did I do it? Let me connect, actually did not do it. So let me connect to east. And as we're connected with east, this is another empty cluster, there is nothing. So let's go ahead and install our global control plane. So I'm gonna copy and paste this, put it here, and press enter. This is going to be installing our remote control plane. Very similar experience as installing the global. And if we look at the pods in the newly created Kuma system namespace, we can see that the control plane is being downloaded right now, and it's running and it's ready. So let's go ahead and follow the instructions. Once we have the control plane remote installed, we also need to install the ingress that we're going to be using for cross-zone communication. When there is a service wanting to enter another zone, it will do that via the ingress. The ingress will do an SNI lookup to determine on the certificate, on the mutual TLS certificate, to determine what is the actual service we're consuming. And to do that, I can just copy paste the commands and install the ingress. And then once we've done that, we can also install the DNS service discovery that Kong Mesh and Kuma provide out of the box. And this is built on top of, it's built on top of core DNS. So let's go ahead, install that as well. And now we've got, if you look at the pods that we have running in this remote zone, we have a remote control plane and we have an ingress, and both of them are running. So let's go ahead and fetch the IP address of our ingress. We're going to be needing this later to activate the zone. So you can see that at the moment, this IP address is pending. We're waiting for GCP to give us the IP address. And here it is. So this is the IP address for the east zone, for the ingress, and this is the port. Now let's go ahead on the other zone. Let's add the, so let's go to the GUI first. Actually, let's add the resource to enable this zone. So to enable the zone, we must go to the global control plane and then add this zone resource. This zone resource tells us the name of the zone and what is the ingress associated to this zone. So let's go to global. Like I said, every change we make has to happen via global. If we try to create a Kuma or Kong Mesh resource via the remote, we're going to be receiving an error. So let's go and create a zone to activate this zone. So basically, this is the east zone that we've just created, and this is the address of that load balancer for the ingress. And so if I execute this on the global, we are activating the zone right now. And if we go back to the GUI, we should be seeing in zones, we should be seeing one zone, east, which is online, and this is the remote zone we have just done. Now the idea here is we're going to be doing this only when we want to add a new zone, right? Ideally, it's very simple to do, but ideally this is not an operation that we're going to be doing often. Once we have all the zones up and running, then we can go ahead and create as many virtual meshes as we want. We don't have to keep doing this every time we want to deploy a new service. Anyways, this is the Kong Mesh West zone. So let's go the same thing. Let's do the same thing. So I'm going to be installing the remote control plane. This time we're going to call this control plane this zone West. And then once that is done, let's go ahead and create the ingress. Once that is done, let's go ahead and create the service discovery. And then we're going to be adding the zone, the West zone, in the global control plane, the same way we've just done with the East zone. Wait a second, a bit longer this time. There we go. So if we look at the Kuma system namespace, the control plane is running. And by the way, this is all that we need. Kong Mesh and Kuma do not really have many moving parts. It's the control plane. And if you want to run it in a multi-zone mode, we have also the ingress and the service discovery. But it is pretty straightforward. We can now fetch we can now go ahead and install the ingress. So I'm going to be following the same instructions that you can follow as well to install the ingress and then install the DNS. And then I'm going to copy paste this, install the DNS. And now everything is there. So we need to get the address of the ingress for this zone, which is pending. We're waiting for Google now to give us, to provision the address. And whenever this is done, we can move on. We're waiting and waiting. It shouldn't take much longer. Usually this is quite quick. It doesn't, there we go. And so this is the IP address of the ingress for West. So I'm gonna put it here just as a reference in case we need to double check it later. But basically what I'm going to be doing is create a new zone resource and activate this zone as well. I'm going to be doing that from the global because again, right now we've installed everything in the remote zone, but if we want to change the status of our mesh, any resource, that has to happen from the global. So let's connect to the global. I've been switching back and forth from one Kubernetes cluster to another, and I hope that's not too confusing. And now I'm creating the zone for West with the ingress that West has on the global. Once we've done that, it creates that resource. We can go back to our GUI, we can refresh, and the West remote is online. We want to add virtual machine-based workloads. We want to add more Kubernetes clusters. We want to add another cloud. We just follow the same operations as I've just showed you, and we can have as many zones as we want. We can have hundreds of zones if we want to. Now that we've done that, there is obviously, the only thing that we have are the ingresses. There is different data plane types. There is the standard data plane type, then there is ingress, then there is gateway. This is an ingress data plane that we can see. This is for the ingress of either East or the West zone. We don't really have any application running. So let's go ahead and deploy an application that we're going to be using to demonstrate this multi-zone connectivity across these Kubernetes clusters that I already have. So to do that, let's deploy the app first in let's say East. So let's connect to East. Now, when we deploy the app, we have to go to use the Kubernetes cluster that we want to use. And let's go in my counter demo. In my counter demo, I do have a little variable here that I can configure, argument I can configure that tells us what zone we're running. So this is the East zone. I'm going to be creating this demo, deploying this demo application on East. And as you can see, we're seeing the Redis service and the Redis deployment, as well as the demo app service and deployment. So if you look at the pods into our newly created Kuma demo namespace, we're seeing that first and foremost, the application is being deployed, and there is 2 containers for each pod. And that's because we are automatically injecting the sidecar proxy based on top of Envoy next to each deployment, next to each pod. So as soon as this is running, we should be having a working application. But if we go to the GUI, we should be seeing the data planes coming online. We're seeing that there is a demo app for Kuma Zone East, and then there is a Redis service for Kuma Zone East. If this is done, which it is, I'm going to refresh. Now we have all the data planes online. So we're seeing the data planes coming online. These attributes are automatically generated, but we can create as many attributes as we want, and then we can act upon them on our service mesh policies. All right, so let's go now on the West zone and deploy the same, let's do the same thing. So we have a one-to-one replica of our demo app on both zones. And here, I'm gonna call it West, so that we know that when we consume it, this is going to be the West region. We create the Redis deployment and service. We create the demo app deployment and service. And if we go back to the GUI, these data planes will slowly come online as soon as the pods, there you go. So we're having the demo app in West and the Redis in West coming up online. So they're offline right now, but in a moment they will be online. They're initializing. Google is now downloading the containers. That's why it may take a while. And there we go. So we do have those 2 also up and running. Perfect. So let's do this. So we're in West right now. So let's do this. Let's port forward our demo application to start consuming it and see what happens. Right now, the service mesh is not doing anything other than discovering and connecting the services. There is no mutual TLS, there is no traffic permission, there is nothing. And so if I do expose my demo application on port 5000, I go here and I consume it, we see that this is the zone West, counter is 0. I can increment my counter. And as you notice, it's not going from one zone to another just yet. it is staying within the West region, and that's on purpose. Without mutual TLS and zero trust security enable, Kong Mesh and Kuma will not enable that cross-zone communication. We want that communication to be secure. That's why mutual TLS and traffic permissions have to be enabled for that to work. So let's go ahead and make it work. Let's enable mutual TLS on our mesh. So enabling mutual TLS, it's very easy. It's a policy that we can enable. Like I said, we can support built-in CAs that we generate. You can provide your own certificates. You can also integrate with HashiCorp Vault if you're using Kong Mesh. So there is different things you can do when it comes to mutual TLS. But the most important thing is to note how easy it is to activate it. So we can activate it on Kubernetes using kubectl. We can activate it on universal deployments on VMs using kubectl, but because we're running on Kubernetes, we're going to be using this example. We can update our default mesh to enable a mutual TLS backend, and the backend is going to be of type built-in, and we're going to be rotating the certificates to the data plane proxies every day. In one resource, we are enabling zero trust security and automatically enabling issuance and rotation of those certificates to our data plane proxies. If we had 10,000 services, 100,000 data plane proxies, we wouldn't have to worry about creating certificates for each one of them or rotating them. Kong Mesh does that for us. This is how easy it is with Kong Mesh to enable zero trust security. So let's go ahead and create, let me add some highlighting here, and create the command that we're going to be using to enable this mutual TLS. Now, to enable mutual TLS without enabling traffic permissions, this will stop our traffic. When mutual TLS is enabled, we must be explicit on what services we want to allow to be able to consume other services. And so let me connect it to the global first, because again, these policies have to be applied on the global, and then the global will automatically synchronize them to the remote. Let me show you side by side what happens when I introduce mutual TLS. So let's go back to the demo app. Where is it? Here it is. Let me copy and paste the command, and then let's see what happens. So I'm going to be enabling mutual TLS. And after I apply this policy, the policy will be propagated to the remote control planes. And then once it is propagated, the traffic will stop working, as we can see here, cannot connect. Now, in order to resume the traffic, we have to apply another policy called traffic permission. And traffic permission effectively identifies what source of traffic can consume what destination. We can use any attribute that Kong Mesh provides. So we can use the service, so we can use the zone. We can use anything. We can create our own attributes if we want to. So in this case, we're going to be simply enabling any service to consume any other service. Simple as that. So let's go ahead and create this command that we're going to be using to re-enable the traffic again. Let me show you what happens when I do that. So right now I'm adding the traffic permission to allow all traffic. This is a traffic permission policy for Kong Mesh. If I do this, the traffic will work, but most importantly, it will work across zones. So let's wait for this to work, and there we go, boom. Let me stop the auto increment just for a second. Right now we are auto incrementing from the West region. We're auto incrementing Redis on East and auto incrementing Redis on West. You're going to be seeing different counters depending on what Redis instance we're hitting. And so if I re-enable this traffic, we see how we have cross-cluster, cross-zone communication out of the box. That was easy, wasn't it? We just had to deploy the remote control planes, deploy our apps, and boom, just works. This is exactly what we've done for the keynote demo that I showed you in the beginning. We can have a virtual machine zone and it would work the same way. If we want to determine different traffic routing rules, so let's say that we want this traffic to go primarily to East, we can do that by using the traffic route policy. There's many policies. There's health check, circuit breaking, but let's use traffic route now. So with traffic route, and we've seen this in my first example, we're going to be now creating a rule that basically says for this traffic path, from this traffic that's made by this source to these destinations, I want to route the traffic to these destinations. And so let's go ahead and fetch our service names that we're going to be using. So we're going to be saying, I want every request made by the demo app to Redis regardless of from what zone this is being originated from. And any demo app making any request to Redis must go to a Redis, 100% of that traffic, all of it must go to a Redis that it is in the, let's say, the west or east zone. So let's go ahead, create the kubectl command that I'm going to be applying to make this change. Let's go to the demo app so we can see what happens. I am applying this traffic route right now here on the global, and I press enter, and we create the traffic route. And as soon as this propagated, all the traffic will go to east. Let's say that we want the traffic to go to west, and this is effectively a data center failover traffic shift that we can implement in one click. This is very, very powerful. We can now, for example, shift all the traffic into west if we want to do that. There we go. Of course, it's much faster because the Redis is being incremented from the same region. This effectively shows you in just a few minutes how we can deploy a multi-zone Kong mesh cluster across multiple Kubernetes clusters. We've seen in the previous demo also the virtual machine zone, and how we can secure the traffic. Right now it's completely secure and encrypted using mutual TLS, and we can use our Kuma GUI to explore that. So we can go to meshes, we can see that mutual TLS is enabled, everything else is disabled. For the sake, we don't have enough time, but for the sake of this presentation, there is going to be other sessions at Kong Summit that are going to be exploring these other features that I highly suggest you go and watch to learn more about all the other features that Kong Mesh provides. And there is only one mesh, by the way, a default mesh. Now let's say that there was another team that we want to support, and we want to provision a new isolated mesh just for that team. We don't have to redeploy this all over again. We can create a virtual mesh to create an isolated environment for that team. And so let's say that this environment is called, application, trading. We can now create this new mesh resource in our global control plane. And once I do that, if I go back to the GUI and I refresh the GUI, we're going to be seeing this other mesh coming online. So in the default mesh, we have all of these different data planes. Application trading is a new mesh. It's compartmentalized. There is no data planes. So now we can support another team, and we can create as many of these meshes as we want. Each one is going to be having policies that are specific to them so that different teams do not step on each other's foot. And if I go back to the default, here we can see the traffic route that we have set up, as well as we can see the traffic permission that we have set up. It is this powerful to create a service mesh for the entire organization. And usually we're seeing with our customers, it takes less than one quarter to go in production with a distributed service mesh. And of course, the Kong team is here to help you as part of the overall engagement with Kong Connect, and the Kong Gateway is here to help you make the entire process very, very easy and seamless. Well, so thank you so much. This is all. We have analyzed multi-zone. We've looked into multi-zone. We've looked into mutual TLS. We've looked into distributed service meshes. We've looked into routing, into traffic permissions. There was a lot that we have done in this session, and I hope this was beneficial to you. You can get up and running doing the same thing I've just did by downloading Kong Mesh on konghq.com from the docs section. And if you have any questions, feel free to reach out. Thank you so much.